All right, so I'll be the next speaker. So I think Kaz was able to explain some of the tools that you might want to find leverage when you build machine learning project. So Google offer a lot of services. It could be like you are just consuming APIs and directly use the models that they have already provided for you to integrate to your projects. You can also reuse existing models or pre-built models, and then you can retrain it based on your data. But in some cases, some of those custom built machine learning, predefined machine learning models available out there wouldn't fit some of your use cases. And this is where one of the tools that Kaz mentioned was TensorFlow. So TensorFlow, as mentioned by Kaz, it's one of the machine learning library that allows you guys to build your own machine learning models, do your training with your own internal data, and then you can leverage on the machine learning platform itself and ecosystem to move what you've been doing in research to production, because that's the main purpose of the ecosystem itself is to move everything that you build on research to move it to production. So my talk is relatively focused on a new version of TensorFlow 2.0. Anyone who have used TensorFlow already, just raise of hands. Okay, cool. TensorFlow 1.x is kind of crazy in terms of how fast-paced they were able to continuously build different types of versions of TensorFlow. So the goal really is to have a much more strategy, or a good strategy, into which providing a much more straight direction on how the TensorFlow 2.0 will move forward. So just to give a brief towards myself, so I am Ralph Regalado. I'm one of the Google developer experts for machine learning. I think across the globe with around 40 plus Google developer expert in the region, with around 15 already, and they've been getting a lot of more technology experts. So Google has their own program called Google Developer Experts, and they relatively select people who are have knowledge in a specific technology and advocate that technologies. So last year I was also been invited as one of the machine learning facilitator for Google training. So I was able to train around 5,000 plus professionals in Southeast Asia region last year. So that's why only few meetups than last year, and I apologize for that. But that gives me a better perspective of how Philippines at par with other how far are we with our peers in Southeast Asia. And then at the same point in time, I do have my own company called Senti Techlabs. So I'm the CEO and founder of it. So Senti, just to give a brief, when we first started, we just do a lot of work in terms of social media analytics, trying to understand Filipino languages and Philippine languages. Since we know Philippine languages is kind of a hard language to work on. A lot of misspellings, gay speak, judges speak, text speak, and then context switch, English to Filipino to Bisaya in one sentence, which makes it around challenging. And we have around 880 plus languages across the Philippines, right? And then we move into working with corporate companies, helping them find ways on how they can use and leverage on artificial intelligence. So we do a lot of consultancy work with corporate companies, providing them direction as to how AI will be involved in some of their processes. So we work with a lot of we work with insurance companies, we work with agencies, marketing and PR agencies a lot for our work. Prior to building my own startup, I'm a former assistant professor in the University Manila. So I've been a teacher for around 8 years, relatively working, teaching mobile development and web development, and doing a lot of research in terms of natural language processing. So if it's on text data, we do a lot of that. So going back to the main discussion, this will be very quick to give way to the next speaker. Kasi minsan lang siya nandito. So TensorFlow has been a great success. So there's a lot of projects already. If you're familiar with, if you're in GitHub, It's one of the leading communities in terms of like creating projects. So it's an active community, and a lot of resources have been around which teaches around the use of TensorFlow. And TensorFlow scope has broadened dramatically, so they have like expanded in different types of how you can leverage on the models that you have built, and it would be like use it to production. You can actually build TensorFlow models which can run on mobile. You can build models which can run on websites using JavaScript. You can also like be embedded, as discussed by Kaz. You can also be embedded by in Raspberry Pis. And TensorFlow is part of a larger ecosystem. So TensorFlow is supported by Microsoft Azure Cloud. You can create, even if it's like a product or an initial effort by Google, a lot of like cloud services, Amazon, Azure, has a full support in terms of like deploying your TensorFlow models. And it's part of a larger ecosystem, so we can leverage on different types of tools and integrate TensorFlow as part of your pipeline for machine learning products. So, and given like a fast pace of development for TensorFlow within Google itself, it has changed a lot because a lot of like contributors have been like finding ways on how they can actually improve the library itself. They are like contributing a lot of like improvements and functionalities to put more power and flexibility on how you can build models on TensorFlow. So, but there's a lot of like challenges that was encountered when it was first launched. So some of these challenges is that was bought because of the high-level APIs. In TensorFlow 1.0 or 1.x, because there's a lot of version, I think the recent was 1.12. There are two types of API. So you have a low-level API, which relatively targets researchers, scientists who would want to like dabble with all of the algorithms, wanted to like build customizations in terms of like building their own optimizer, building their own gradients, and how to build this flow in terms of like building their deep neural networks. And you have like high-level API, which it's more of like targeted for first-timers who don't want to like understand first the complexity of how the models are built, but the high-level API is already good enough for them to like build very, very quick machine learning models. But a challenge for 1.x version was is like there's too many high-level API, which like makes everything so confused on what should they use, and it's more of like, will this be supported on the next release? So that's relatively keeping them questioning like what's the strategy of like building this API. So we have 3 APIs available. The high-level APIs, you have the TF layers there, in which you can build your various like deep learning models. You have your TF estimators, so they have their own like pre-made estimators. They have like linear regression, logistic regression that you can use, and you can also like build your own custom estimators. And then they have also like adapted a standard API for API standard for machine learning, which is TF-Keras, which is now like the high-level API that uses TensorFlow as a backend. So just relatively, all of this can allow you to build different deep learning models, but it's kind of like too many, too confusing, and you don't know like which is a much more appropriate high-level API to use. So in TensorFlow 2.0, the main focus is relatively to provide simplicity and ease of use. So the main model or the main like programming or the main APIs that they will be focusing on is relatively building it on Keras and applying eager execution. And what makes TensorFlow 2.0 unique is for you to easily bring your developed machine learning products easily into production. Okay. And as also a way for us like to also support scientists and researchers who are using and leveraging TensorFlow 2.0 by providing them a way of various of tools to perform experimentations for research. And since there's a lot of contributions across an active community of TensorFlow, they have also like tried to simplify the API by removing some of those repeated functionalities and trying to segment if this is a contributed like work. We shouldn't push that to the main like TensorFlow libraries. So try to like clean and have a much more procedural or have a much more clear process on how they move a functionality built by the community and move it to the library itself. So in TensorFlow 2.0, they have at last define a much more clearer architecture. So you have like two separate steps, right? So you do like machine learning. We have training and then you have your deployment. So in training, you have there several like features that you can use. You have now a much more better like data pipelining for TF data. And then, as mentioned a while ago, they have two main high-level APIs, which is no focus on. But again, the recommendation is relatively build your high-level APIs or build your models on top of TF Keras. But you can still use the pre-made estimators for some of the machine learning libraries that you would want to still use. Like, as discussed by Kaz a while ago, you can access linear regression models and then logistic regression just by using pre-made estimators. And what's unique that they have added on TensorFlow 2.0 is the distribution strategy. I'll be discussing this later. And then you can do training on different types of like processors. You can run it on CPUs, you can run it on GPUs, you can run it on TensorFlow processing units on the cloud itself. And the main output of that is like a save model. And your save model, you can bring that on different deployment options that you would want. I think the save model can also like be deployed on TensorFlow serving if you would want to have like an API or GPRC access. TensorFlow Lite, TensorFlow JS, I'll be discussing this later. But this is the entire architecture. So TF 1.x to TF 2.0. So as mentioned a while ago, they would want users to have a much more like smooth engagement and smooth use with the library. So the main standard API standard now that they would be using is the Keras itself. And it would be like central for all of the high-level APIs and high TensorFlow integration within the entire TensorFlow ecosystem. So if you previously like used TF layers in 1.0, they would want you like to leverage TF Keras library in itself. So for example, in TensorFlow 1.x, this is like the coding style. So you have your, if you still like familiar with this math multiplication a while ago, the linear model that Kaz was able to explain, and then you need to like build your own TF sessions, and then do some initializers to like run the entire training set. But you need to also like feed the model directly, so you have feeding, you have your training data, and then you have your training labels to like run the entire training. In TF 2.0, it's much more simplified. So simplified into this, and they have added like the distribution strategy. Okay, where are you going like to do on the training itself? What type of distribution strategy that you would be working? Are you doing it like leveraging several GPUs or TPUs? This is extremely relevant if you have a large, huge data set of training that you would want to actually use. So, but we will not be talking about distribution strategy. This would be like a different like topic. But this is one of the things that they added as part of TF 2.0. So, what is the current workflow now? So it's much more like defined in terms of previous versions of TF 1.0. So you need to load your data using TF data. In some of the cases, previously in 1.x, even if you have your CSV file, you can load it. But since they have a much more like clearly defined that TF data would also be used for the distribution strategy, so it's more recommended that you use and load your data using TF data. And then you build, you train, and validate your models with TF Keras, or you can leverage and use pre-made estimators. Okay, as mentioned, there's also ways like pre-made estimators that you can use, or you can build your own like deep neural models using TF Keras itself. And then you can run in debug with eager execution. I'll be discussing this, but you can use autograph for the benefits of graph-based execution. So there's two main points on number 3. So you have eager execution, and then you also have like graph-based execution. So there are two types of mode in which you can run TF 2.0. So you have like your eager mode and then the graph mode. So what's the difference of it, right? So eager mode is much more intuitive. It's much Python-like way of coding. But a challenge of this is like we cannot leverage yet some of the capabilities of the graph mode, which can use and be run on TPUs. So if you are like wanted to a much more performant way of building a model and leverage on some of the distribution strategies, such as like using TPUs, it's still recommended that you use it on graph mode. But again, you can leverage both of the two modes because each of them has their own benefits. You can quickly like build models and do debugging on eager mode. But it's recommended that you are going to deploy your model now to convert it into graph mode. So because it's much more performant, at the same point in time, try to leverage on the distribution strategy for training. And a way for us like to leverage both of the capabilities is they build what we call as an autograph to translate your eager mode code into a graph mode. Okay, so that is much more easier for you like to leverage both of the opportunities of eager mode and graph mode. So this is where the autograph comes in. So that's number 3. So again, you can run and debug with eager mode, and then you can use the benefits of graph-based execution when you run your model leveraging TPUs and GPUs to run your graph because it's much more performant. Next is the use of distribution strategies. As mentioned, that's part of the TensorFlow architecture. And then next is, at the end, is to export it to the same model. So the main purpose of the same model is like one simple model that I can easily like translate and use and convert for TensorFlow for mobile and TensorFlow for web. So going back, so the main output is like same model. So we're able to discuss several the training process. We weren't able to cover TensorFlow Hub. So TensorFlow Hub, it's a repository of like pre-built models that you can use already, or you can like modify some of these codes through transfer learning. Okay. So for deployment, so once you have already trained and saved your model, you can use like TensorFlow to like build it. You can serve it using one of these deployment libraries. So you have TensorFlow serving, you have TensorFlow Lite, you have TensorFlow.js. So TensorFlow serving, if you would want to like serve it by a call of an API, you can leverage on TensorFlow serving. If you would want to deploy your models as a mobile application, so you can use TensorFlow Lite. So if you convert your TensorFlow project into a TensorFlow Lite, you can deploy it for iOS, you can deploy it for Raspberry Pi, you can deploy it also on Android devices. So there's no issues with in terms of like, is there a limit if I just go into like use TensorFlow Lite. So it has support for iOS and Android. And then you also have like the TensorFlow JS. So TensorFlow JS, you can actually like run your models on a JavaScript library, and then you can also like do your own training on TensorFlow.js. In TensorFlow Lite, the limitations for this is you cannot do in training on the mobile itself. You need to build it separately. So the purpose of TensorFlow Lite is just purely for the deployment itself. But TensorFlow.js, you can train, and then you can like serve the model that you build using TensorFlow.js. So each of this like would be probably a different topic for the next meetup that we'll be discussing with. So right now, TF 2.0 is on a developer preview. You can access it through this link. If you would want to play with it, that would be best. Some of my teams at Senti are like the one playing around the version 2.0. Since we're like using TensorFlow on our projects. So yeah, if you would want to play around with it, and if you have any like comments on TensorFlow, best to like approach me so you can like, escalate that to the team itself who's like developing and working on this. So yeah, that's it. If you would want to know more about TensorFlow, you just go to tensorflow.org. All of the installations are there. Some of the sample codes are also available in tensorflow.org. That's it. Thank you. Any questions aside from any questions?